Wow! How cool is that? Jupiter coming that close to Saturn. Now I know Copernicus predicted this event, but not for another few days. I know I could predict better than this. With my giant sextant for elevation measurements, I will gather the most accurate data known to mankind.
Over the next 20 years, Tycho gathered extremely accurate data of the planets and became very famous in Europe for doing so. In Austria, at about the same time, a mathematician named Johannes Kepler was struggling to make sense of the mathematical understanding of the planetary motion. I've tried concentric circles. I've tried putting polygons inside each other. I've even tried all the perfect solids. Nothing is working. Nothing! The solar system has to follow the rules of geometry. Its motion is too perfect for anything else. I know! The data I'm using to check my results must be inaccurate. That's it! I've got to see Tycho Brahe, no matter how much of a giant weenie he is.
Kepler's 3 laws of motion are right up there and sit next to Newton's universal law of gravitation. These two concepts are very much tied to each other because they involve the study of the behaviors of planets. And so both concepts were tied to circular motion. And that's why both these lessons are here where we're at. Yes, they both seem to be kind of cul-de-sacs on the curriculum road here, but nonetheless they fit here and are described here. Since the beginning of time, humans have been observing the heavens. And with the universal law of gravitation and the understanding of how the planets moved, scientific community's understanding of the behaviors of heavenly bodies was topped out. These are two huge intellectual pieces. Huge. Now, the tough part about it is there's no real mathematical derivation that leads us to these thoughts. And that, to me, is what makes them absolutely awesome. I mean, huge in scope, but grand in what they actually mean. Because there's no manipulation of other equations to get us here. It's based off of data and thought. And to me, that's amazing. Now, Kepler's 3 laws are pretty simple. It took 16 years to derive these laws, but nonetheless, they are as follows. Number 1, all planets move in ellipses. Now, this lesson was driven by 2 objectives. The first was to determine or describe Kepler's 3 laws. The first one was all planets move in ellipses. Well, in an ellipse, the sun is at one focus such that the sum of these 2 distances, which is the distance from the planet to each of the focus, remains constant. Now, the motion of a planet around an ellipse is ultimately the result, the consequence of the force being inversely proportional to the square of the distance of separation. Now, this is really a cool thing because Kepler figured this out way before Newton did. And so that makes it very powerful. Now, Kepler's second law was equal areas are swept out in equal times, which once again is a result, a consequence of an always varying force due to the inverse square law. And so what we see is that in an equal amount of time, which we called 3 months, here and here, an equal area was spanned out. Now, Kepler's third law was more of a reflection of understanding between how long it took to get around one orbit and the distance the object was away from the sun. because we know the force varies with distance, then that should certainly affect the speed at which it travels around, thus the time it takes to complete one orbit. And so we ultimately looked at the centripetal force acting on it being the force due to gravity, which is due to Newton. This is in direct response to Newton's universal law of gravitation. But we whittled it down to understand what the constant was. Now, Kepler got to this point. He got to this point, and this is more a reflection of a lot of mathematics resulting in this in comparison to Brahe's data. However, if we bring in the centripetal force, this is the piece Kepler missed. He didn't understand what or how this happened, just that it did happen. This is, it did happen. This is a reflection of how it happened. And so by following through with this train of thought, we see that the square of the period is proportional to the cube of the distance of separation. Now remember, this distance of separation, this r, is between the centers of mass. But when you're dealing on the planetary level, the distance between the two bodies, here's the moon, here's a planet, the distance of the radius is pretty negligible when you're considering the distance, the physical distance between the two bodies themselves. So many times they're looking and considering these as point masses. But if it is close, like any satellite in the Earth or around the Earth, the distance of the satellite to the Earth is not a significant value so much to ignore the radius of the Earth. So just as in our study of Newton's law of gravitation, pay attention that this is the distance between the two centers of mass. Now the second object was to demonstrate an understanding of Kepler's law by using them to determine different functional variables within the third law. For that and its applications, I invite you to go see the examples in office hours.